Hello everyone, welcome back to Technologies Discussion channel. For this video, I'd like to continue the discussion on RF mixer. There are actually two objectives for this video. Firstly, I will explain what will be the role of an RF mixer. Next, I'm going to explain why RF mixer actually play a crucial role in a wireless communication. So basically, these are the two objectives of this video. Guys, this is my email. If you have any question regards on this discussion, please drop me an email. Okay, or if not, I actually prefer you guys to ask me your question through the comment. Before I continue, I'd like to urge you guys to help me by like this video. Guys, just a few seconds. Help me. It's free also. Press the like button now. For those who are new to this channel, please consider to subscribe and turn on your notification bell. Once again, thank you so much for strong support. Let me explain the roles of RF mixer. So in fact, RF mixer play a very critical role in any wireless communication. So in short, they actually translate the information signal to a new frequency that is appropriate for transmission. Let's take a look on this diagram in order to understand better. For example, this is the information. This is the information that I want to send to a receiver. So before they actually send to a receiver, they go through a mixer. So the idea of mixer is to shift the signal from a low frequency to a higher frequency in a transmitter. This is what we know as up conversion. So the mixer actually just changed the frequency from a lower frequency to a higher frequency. So from here, you can see that the information, the shape and the size remain intact. On the other hand, okay, for a receiver, this is what we call a down conversion. They basically shift from a higher frequency to a lower frequency. And again, you can see that the shape and the size of the information remain intact. So basically, this is actually the role of RF mixer. Next, let me explain why we need RF mixer. So in fact, there are actually four reasons. This is the first reason why we need RF mixer. This is because the antenna can be smaller. Let me explain. This is what we have discussed earlier on. This is actually happened in a transmitter. The frequency actually shift from a lower frequency to a higher frequency, and this is what we know as up conversion. So let me explain how does the antenna actually become smaller. This is actually the size of antenna, which is quarter wavelength. This is wavelength divided by 4. Okay, so let me explain this essential formula. Okay, so this is actually C equals to F lambda. C can be the speed of the light or can be the velocity of the EM wave. This F, which is the frequency of the signal, this is actually the wavelength of the signal. So now what actually happened is when we are able to shift from a lower frequency to a higher frequency, which means that this frequency actually increase, while the speed of the EM wave, they basically remain almost the same. It is always very challenging to increase or decrease the speed of the electromagnetic wave. So this is actually most of the time constant. When we are able to shift the frequency to a higher frequency, this simply means that the wavelength actually reduce. So once the wavelength reduce, the size of the antenna actually reduce. So this is what happened is when we actually has a higher frequency, we are able to make the antenna smaller. And basically, this is one of the essential why we need RF mixer, because with a compact antenna, and it actually also weight lighter. This is the first reason why we need RF mixer. The second reason, spectrum sharing. Okay, so this actually allow us to move the information into separate channels in order to share spectrum and allow simultaneous use. What does this actually mean? Let me use FM receiver in order for us to understand spectrum sharing. For example, this is actually the FM receiver. Let's say without the mixer. So let's say if we want to listen to 3 different broadcasts, FM broadcasts, then we need to have 3 different receiver because the receiver exactly due to the broadcast that you want. For example, let's say I want to listen to this station, then this receiver will be catered to this station. Let's say I want to listen to this station, then this receiver will be basically tuned to receive this so-called base station. So what is the role of this mixer? So from here, you can see that by properly control the LO over here, you can see that I actually can shift the channel of the different FM. So basically, let's say if I want to receive this signal here, I can properly tune the LO in order for the receiver to tune into this session of this radio podcast. So this is the second reason. This actually allows spectrum sharing, which means that I only just need one receiver and I actually can tune throughout the whole FM broadcast. Which channel I want to listen, I can basically tune it with a local oscillator. So this is the second reason why we need RF mixer. The third reason why we need to have an RF mixer. So basically from here you can see that with RF mixer, then we can have RF and also IF, intermediate frequency. Let's understand a little bit more. So basically let me highlight the RF amplifier and the IF amplifier. They actually play different role. For example, for RF amplifier, they actually amplify the incoming high frequency signal. As you can see from here, this is what we receive from the air. They actually amplify this high frequency signal directly from the antenna. So the key purpose of RF amplifier is to boost the weak signal. Okay, so they actually increase the gain slightly, not that significant. The key idea is to improve the sensitivity while keep the noise as little as possible. So this is actually the role of RF amplifier. Let's come to the IF amplifier. So basically this is where the IF amplifier should be. They are actually after the mixer. So they actually amplify the signal, okay, after it has been converted to a lower fixed intermediate frequency. So the key purpose is they provide most of the gain. So most of the signal gain is actually amplified at the IF amplifier. They also provide a better selectivity. So over here you can see that both the RF and IF amplifier play a different role. So let's say without the receiver, this IF amplifier will be more or less the same of RF amplifier, and hence they will not be able to amplify the signal because, as I mentioned earlier on, most of the signal is actually amplified by IF amplifier. So therefore, we need to step down the frequency before we can do a gain improvement on the IF amplifier. Guys, before I come into the fourth reason why we need RF mixer, okay, so the fourth reason is slightly complicated. So before I come into the fourth reason, I'd like to urge you guys to help me by like this video. Guys, it's free, just a few seconds. Help me, press the like button now. If you have learned something from this video, I urge you to support me by subscribing to this channel and turn on your notification bell. Once again, thank you so much for strong support. Before I come into the fourth reason why we need RF mixer, okay, I need to explain what is actually high Q and low Q, as you can see from this diagram here. Typically, for high Q, okay, which means that a higher selectivity, you can see that the bandwidth is actually very narrow, and you can see that the skirt of the filter is actually very steep. As for low Q, you can see that the bandwidth in general is much wider, and you can see from the skirt, okay, they are actually much more gentle as compared to the high Q. So now let's come to the fourth reason why we need RF mixer. Okay, so in RF design, okay, a mixer can actually allow a higher effective Q by down convert the frequency. When we actually down convert the frequency, okay, so this will let us to have a better design in terms of filter because the Q can drastically reduce, which I'm going to explain on my next slide. Let me use an example to explain, okay, why Q actually improve after mixing. Okay, so this is actually the formula to calculate the quality factor, okay, which is the Q, which is the frequency over the bandwidth. Now, there are actually two ways to calculate. One is with the RF frequency, another one is the IF frequency. Typically, RF frequency is much, much larger as compared to the IF frequency. For example, for this case, let's assume that RF frequency is actually 2 gigahertz, while IF frequency is actually 2 megahertz. If you still remember, the purpose of the mixer is to shift the frequency up or down. The shape and the size of the information remain intact. So therefore, the bandwidth will be the same for RF or IF frequency, which will be 10 kilohertz. Now let's look up the Q for RF. Okay, so as I mentioned, the frequency is actually 2 gigahertz. So from here, you can see that the Q, which is around 200K, it is almost very challenging to design a filter with a high Q of 200K. So basically, this is almost impossible to design. So when we actually shift the frequency to a lower frequency, you can see from here, this is actually the IF frequency, which is much, much lower as compared to the RF frequency. You can see that the Q become 200. So basically, this Q is still manageable. We can still design this filter with a Q of 200. So basically, in short, when we actually do some form of mixer, if they actually lower the center frequency, this make this high selectivity achievable with practical circuit. So basically with this, I like to end my discussion. Please help me to like this video and subscribe to this channel. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you so much.